Hi, this is Mrs. Cahill with your notes 3.4. We are graphing relationships. On number 1 on your note-taking guide, we are asked to evaluate the following expressions given the functions below. So I see these 4 different functions. One's g of x, f of x, h of x, and j of x. And they've asked me on part A to evaluate g of 10. Well, that means I will use this function first. So g of 10 is equal to, now we plug in our x as 10. So we have negative 3 times 10 plus 1. And just simplify. G of 10 is equal to negative 30 plus 1. G of 10 is equal to negative 29. That's the answer. Keep in mind, we have the ordered pair 10, negative 29. And we do the same thing for each one of these questions. So I want you to go find f of 3. Clearly now you're going to use that function. So I have plugged in 3 for x into this next function, and now we simplify. 3 squared is 9 plus 7, and we get 16. All right, do the same thing for h of x, but again, pause the video and compare your answer with mine. Also, while you're at it, do j of x as well. For h of negative 2, when I plugged in negative 2 for x on h of x, 12 divided by, oh, and I copied that down wrong. There we go. So when I plug in negative 2 for my x, I've got 12 divided by negative 2, and out comes negative 6. So when you do the last one, again, pause, please. When we plug in 7 for x on j of x, 2 times 7 is 14, plus 9 is 23, and out comes 23. Okay, now let's move on to number 2. They want us to find h of 3, so we just have to plug this in carefully. I will say, watch out for that negative sign right there. H of 3 is equal to, so that negative sign is this one. Now plug in your, and here is this 3. Now we'll plug in our 3 that is x, and we'll square it. So h of 3 is equal to negative 3. 3 squared is 9 minus 4. Remember, you do have to use your order of operations. We will square before we multiply. That gives us a negative 27 minus 4. And we get a negative 31. Just so you'll remember, we do have the ordered pair 3, negative 31. All right, let's try number 3. Find g of negative 1. So g of negative 1, let's plug these in carefully. Here's this negative sign. Here's my 2. Plug in your negative 1. Please use parentheses. Minus 2 times negative 1. So order of operations says I'm going to square that first. Negative 1 times negative 1 is positive 1. And I can continue to work right. Negative 2 times negative 1 is a positive 2. And so we've got negative 2 plus 2, and we have 0. That really means that when we plugged in negative 1, out came 0. Okay, let's try some more. Number 4, we're going to find each value using the graph. So look carefully. They want us to find t of 0. So this function's name must be t, and that means we're finding when x is 0. Here's where x is 2 and 4 and 6. X of 0 happens here, but it also happens here. So this is the ordered pair 0, 0, and this is the ordered pair 0, negative 4. What they're looking for is, hey, what is the y value when we plug in 0? The answer to the question is 0 and negative 4. We were asked to find out if this was a function. Do you remember our vertical line test? if we grab a vertical line, I see that it touches my function in more than one place. So that would make this not a function. All right, let's do the next one, k of 0. That means I want to find out when x is 0 on this function k. So we agree x is 0 is here. That hits at this ordered pair, which is 0, -3. So k of 0 happens at -3. On this graph, e of 2. So where is x2? That happens here, and our graph is hitting here, and I believe that's at -1. Number 5, Ahab is buying magazines. This equation shows the total cost, y, depends on the number of magazines purchased. Fill in the table to show how much each magazine costs. So we'll pick our own x values. I love to pick 0 whenever possible. If I were to plug in 0 into that equation, y equals 9 times 0, wouldn't I be spending $0 if I bought 0 magazines? And now when I go to choose my next x value, I have to keep in mind what's the most total cost that will fit in here. This graph only allows me to go up to 12. So I know that if I plug in a 9 times a 1, that y will equal 9. That will fit. And I won't have room for more points on this particular graph. So if I plot the point 0, 0, and 1, 9, I have my function. Technically, this function is discrete, so because you can't buy half a magazine. So on this graph, I'm only able to fit those 2 dots. So when you get more math and they have a problem like number 6, I want to show you something you might need to do on your own scrap paper. Ahab is buying clocks. This equation shows how the total cost, y, depends on the number of clocks purchased, y equals 2x. Complete the graph to show how much Ahab would spend. So we need to make a table of values. Can he buy negative clocks? No, he can't, but he could buy 0 or 1 or 2 or 3. Get as many values as you think you need, and now we just plug those in. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. And now we can graph that. When you don't buy any clocks, you spend no money. When you buy 1 clock, it's $2. 2 clocks is $4. 3 clocks is 6. And we can actually keep going. I see the trend, don't you? We're just going up 2 every time. So I completed my graph, and that's a big hint. We went up 2 every time. So how much does each clock cost? It costs $2. Double check on Get More Math. I know they'll want the dollar symbol because it says label is required. Not sure if you'll want the decimals afterward. All right, let's keep going to the back of our worksheet. We're going to graph the following equation. So this time we've got a fraction in our equation, y equals -1/5 x. So I'd like to pick numbers that make my life easy. 0 is always incredibly easy. When we plug in 0 into that function, anything times 0 is 0. So when we plug in 0, what comes out? 0. Love that one. On Get More Math, they're only asking you for one other point, and that is fine if it's linear. If we want to choose another value, so far we have chosen 0. We would want to choose multiples of our denominator, which in this case are multiples of 5. So we could plug in y equals -1/5 times 5 over 1. Then y would equal, well, those 5's cancel. Don't lose track of your negative. Y would equal -1 when we plugged in 5 for x. What if we plugged in 10? Y equals -1/5 times 10 over 1. If we Reduce, 5 goes into itself once, goes into 10 twice, and y equals negative 2. Don't lose track of that negative. When x is 10, y is negative 2. And actually, that last point won't even fit. If we'd like to get one more point that does fit, what if we plugged in negative 5? Y equals negative 1/5 times negative 5 over 1. Well, the 5's cancel, and so do the negatives, and y would equal 1. When x is negative 5, y is positive 1. So let's graph the points that fit. We definitely have 0, 0. When x was 5, y was negative 1. When x was negative 5, y was positive 1. Now that's a continuous function. There's nothing about it that says we don't have points between the points. We only chose the ones that were easy to graph. So we would, on our Get More Math, select the line and then just drag it amongst our points. If this were on paper, I would tell you to add arrows, but I believe Get More Math has that for you. Number 8, let's graph those. So do you see this 1/4 here? It would be really smart of us to choose very nice numbers for x. Let's make our table. Nice numbers. Well, I love 0. And 4 is a multiple of 4. How about 8? And while we're at it, negative 4. We're choosing our values carefully because it would be nicer to plug in. So let's try 0 first. Y equals 1/4 times 0 minus 2. Well, 1/4 of 0 is 0. So y is negative 2. When we plugged in 0, out came negative 2. Let's plug in 4. Y equals 1/4 times 4 over 1 minus 2. Well, 1/4 of 4 is 1 minus 2 gives us negative 1. So when we plugged in 4, out came negative 1. Why don't we go back and plug in negative 4? You do so on your paper. Pause the video and compare with mine. So when I plug in negative 4, the 4's cancel, but don't lose track of that negative, and we get a negative 1 minus 2, which is a negative 3. When we plugged in negative 4, out came negative 3. I'm actually not going to plug in this 8 because I look on my graph paper, there's not quite room for 8 anyway. So when x was negative 4, y was negative 3. When x is 0, y is negative 2. And when x is 4, y is negative 1. This is a continuous graph, so you would grab the line and put it across. Yeah, if this were on graph paper, I would expect you to add arrows to show that that goes on forever. Number 9, let's make a table for that one. By the way, something special on this one. That square right there is going to change the shape. It is no longer linear. So after we make our table, we're going to need to pick not the line, but the other option. You'll change it to the parabola. Also, on their table, they only give you room for 2 points. But if this were on real paper on a test for me, you would need to use 5 points. So that's what I'm going to demonstrate for you. Whenever I'm graphing something and we have an exponent of 2, these are my favorite domain values to choose when I get to pick my own, and I generally get the shape of the graph that I need, enough points to know the shape. So I want you to plug in those values. I'll do them, but I want you to pause every time you do them and then compare yours with mine. The first one I'm going to plug in is 0, only because I love to plug in 0. It's the easiest. So when we plug in 0 into our function, 0 squared is 0. 0 times negative 2 is 0 plus 1, and we get 1. So when we plugged in 0, out came a 1. Now let's plug in 1. You pause and try on your own. 1 squared is 1 times negative 2 is negative 2 plus 1. Negative 2 plus 1 is negative 1. So when we plugged in 1, out came a negative 1. Now plug in 2. When we plug in 2, first we square, order of operations, 2 squared is 4 times negative 2 is negative 8 plus 1 is negative 7. Now, when we go backwards and fill in the rest of the table, you're going to notice something kind of interesting. So let's go back and we'll plug in our negative 1, pause, and you do it without me. So negative 1 squared is positive 1. Please don't multiply negative 2 times negative 1 and make things positive. Order of operations says we have to evaluate that exponent first. Negative 1 squared is positive 1 times negative 2 is negative 2 plus 1 is negative 1. Hey, didn't we get a negative 1 earlier? We did. Watch the next one. Now go plug in your negative 2. Pause and compare. So negative 2 quantity squared is positive 4, but times negative 2 is a negative 8, plus 1 is negative 7. So do you see the pattern here? The negative 1s repeated, and then the negative 7s repeated. Oh, and I meant to write negative there. So let's go ahead and graph that. On Get More Math, they're only going to have you graph 2 points, but I would recommend you do more than that. On here, honestly, you could have put in 0 and 1, 2 and negative 7. Any of the points I believe would work, but if this were on paper, I would want 5 points. So let's go graph those points. When x is 0, y is 1. When x is 1, y is negative 1. When x is 2, y is negative 7. And going backwards, when x is negative 1, y is negative 1. When x is negative 2, y is negative 7. Now, this shape, if we were to connect it, it's continuous. There are points within the points, and it creates a parabola. On Get More Math, they kind of make it easy for you. If you change from the line to the parabola, you'll be able to graph it once you put in your 2 points. All right, let's try that again. I want you to make a table. Again, I highly recommend 5 points, and these 5 points are beautiful. 0, 1, 2, and negative 1, negative 2. I'd like you to complete your table and then compare yours with mine, and we'll see what we get. You should do the entire thing on your own. So I have plugged in my 5 values and completed my 5 ordered pairs. You should be able to plug those in and do the same. On Get More Math, remember, you're going to not choose the line, you're going to pick the parabola shape. You can pick 2 points to plot. I could plot 0, negative 2, and 1, 0. While I'm at it, in real life, I would have you plot more points. I would plot the point 2 and 6. And let's do the other side. When x is negative 1, y is 0. And when x is negative 2, y is 6. Notice again that symmetry, and then we can connect that with a curve. Should always look curvy, should not look like a V. So if you were ever doing this on the test, you would make your graph look like that. All right, these last 2 are not on Get More Math, but I want you to see them. So on this next equation, I don't have it in the usual form I'm used to seeing. We've called it slope-intercept. I want to get my y alone. Here's what I have right now. Well, to get y alone, wouldn't I just need to get rid of this 2x? His opposite is minus 2x. And we have y equals 12 minus 2x. However, I'm going to write that in proper slope-intercept form. And y equals negative 2x plus 12. Once again, you'd want to make a table for your x and y values. This will be a line because we do not have x being squared or y being squared. So we'll have a line, and technically 2 lines make a point. Why don't we plug in 0 for x? So negative 2 times 0 plus 12. Negative 2 times 0 is 0 plus 12 is 12. When we plugged in 0, out came 12. Will that fit on a graph? Yes, it will. Here's 0 for x. Let's go up to 12. That's 1 point. And honestly, one other point would make our line. I don't dare plug in something that will get me off the graph. I don't want a 14. So let's choose carefully what will get us onto our graph. We could just try 1. I'd like to go further out. What if we try 4? So negative 2 times 4 plus 12. Negative 2 times 4 is negative 8 plus 12, and we get a 4. When we plugged in 4 for x, we got 4 for y. And that's our one other point, and we've got our line. A third point would actually prove that we've got those other two in line. Let's go ahead and get a third point and plug in 6. So if we plug in 6, we've got negative 2 times 6 plus 12, negative 12 plus 12, and we get 0. When we plugged in 6, we got 0. And those are in line, and you could connect those with a straight edge. When you have 3 points in line, you are pretty much sure that you have not made a mistake. Let's do the last problem. On number 12, they're giving us this function, and they want us to graph with just that domain. So let's try that one. First, let's get that equation with y alone. The first thing I would do is add 3x to both sides. We have negative 5y equals 3x plus 20. And now to get y alone, we would need to divide by negative 5. We should divide each term on both sides by negative 5. Those cancel. It's why we chose it. And the way you're going to rewrite this fraction, I have a 3 over negative 5, but I know I should move the negative out. And I'd like my x pulled out separate from the fraction. 20 divided by negative 5 is negative 4, or minus 4. So now we're set to graph that one, and we're going to choose their domain values. They want us to use negative 10, negative 5, 0, and 5. Since we need to get 4 numbers, I'm very glad that we made the effort to get y alone. It'll be easier when we go to plug in x. So I want you to, one at a time, go plug in your different numbers for x and see what y becomes. You can compare your work with mine. So when I plugged in negative 10 for x, negative 3/5 times negative 10 is negative 6, minus 4 is negative 10. All right, go do the same thing for negative 5. Well, I certainly hope you caught my error. When we plug in negative 10, negative 10 times negative 3/5 is a positive 6, and positive 6 minus 4 is 2. Thank you for being patient with me. Now let's plug in negative 5. So negative 5 times negative 3/5, the 5's cancel. Our negatives become positive. We get 3 minus 4, and that's our negative 1. So when we plug in our negative 5, the negatives cancel. We do get our positive 3, and 3 minus 4 is negative 1, and we are set to plug in my favorite value, which is 0. So when we plug in 0, negative 3/5 times 0 is 0. 0 minus 4 is negative 4. And the last thing we need to plug in is 5. Finally, when we plug in our 5, the 5's cancel. Don't lose track of the fact that we've got a negative 3. Minus 4 is negative 7. So then you are set to plot those points. If they line up, then we didn't do anything wrong. When x is negative 10, And will that fit on our graph? Yeah, it does. When x is negative 10, y is 2. When x is negative 5, y is negative 1, and we kind of have to put that one in the middle there. When x is 0, y is negative 4. And when x is 5, y is negative 7. All right, if those line up, then we've done something right. Do you see one of my points doesn't line up? It's this guy, but it's not because I made a mistake here. I made a mistake when I graphed it. So let's erase that guy and let's replot him. Here's negative 4, so wouldn't negative 5 be here? And we come down to negative 1, and that is spot on the graph. You do need to use a straight edge whenever you put these in paper because it will save you from the exact mistake that I made.